Hello, warm welcome from my side. My name is Sebastian Schneider. I'm the product manager for the transformer differential protection as well for the generator differential protection. Today I have the honor to present the topics of the differential protection for the transformer, but here we made the introduction for our webinar. So that means now in series we have up to 7 webinars about transformer protection, engineering, CT recommendations and so on. I will do that together with my colleagues Nina Hühn and Klaus Wagner. Enjoy the different webinars and ask some questions. Thank you very much. Okay, so today I would like to give you in the first webinar an overview about the general and the device overview about transformer protection within Z-Protect 5. When we talk about transformer protection, so then we talk about always 2-winding transformer, 3-winding transformer, auto transformer, multiple winding transformer. So, and why we need for that application Z-Protect 5 device? Because Z-Protect 5 is very flexible, as you know from your experience so far. So that means we have now a powerful functionality. So that means our hardware is flexible as well as the software is flexible. You can extend the hardware, the basic module, to up to 9 expansion module, also in the second row. So, and also the modularity in terms of the flexibility of communication is also given. So that means you have the flexibility, the full flexibility in hard and software, and also in software means that we do not support only this, the 87T, we also support the generator differential protection, the motor differential protection, as well as the line differential protection, distance protection, and so on. So that means that the transformer protection device 7UT8 is much more flexible than you know, maybe. And here as well, beside all the protection functions which you can instantiate from the library into your project, you can also instantiate control functionalities like the voltage regulator. So that means Z-Protect 5 is much more flexibility than you know or than you already know. So that means here you can build your device which is fits to your application. So, and when we made the step here into the first device of our transformer protection series, then we see here the 7UT82. 82 series stands for the non-modular series, so that means the device is only 1/3 housing the base module, which contains the measuring points for 2 transformer sites. And when we have a closer look here into the profile, then you see, okay, this device is suitable for 2-winding application. That means we support 1 differential protection for standard and auto transformers. We support with that device 2 3-phase current measuring points and 2 single-phase measuring points. Voltage is not available here in that device. So that means if you want to have voltage as well, then you have to go to the modular series, which is shown afterwards. So these, 7UT82 is suitable for differential protection. So that means we have the restraint characteristic, we have the fast tripping stage, we have an unrestrained stage, we have flexible vector group adaptation, inrush and overexcitation detection, CT saturation detection, and here also we support the restricted earth fault. And as well as we have temperature monitoring on board, so that means also here IEC 6150 communication is possible, and so on and so on. Then we come to the next slide, and here you see the first modular device, which is, of course, looks similar. So that means this device is expandable. That means this device can support up to 2 sites, but if you want to have the flexibility to extend your 2-winding transformer maybe to a 3-winding transformer, you can add 1 additional side to your project. And here's the limitation for that device, and we go also to the profile here of this device. That means the limitation is here up to 5 3-phase current measuring points, 5 single-phase current measuring points, 5 3-phase voltage, and so on and so on. So, but of course, these devices now expandable. That means you can add additional I/O modules to your basic module, and you can select your hardware to your needs. That means you can add voltages, current, binary in and outputs, and so on to the hardware. So the limitation for the 7UT85 is more or less the same as for the 7UT82. That means this device is supporting one-time protection function for standard and auto transformer, but here also we have 2 times the restricted earth fault as main functionality. So if we have a look into the device functions, you will see the device functions is also similar to the 7UT82, but now we have the flexibility of the numbers of measuring points. So the next step is that we have the 7UT86, which is basically the device for 3-winding transformer. Also here we have the possibility to extend the 3-winding transformer to a 4-winding transformer by instantiating an additional transformer sites. Here the limitation is that the limits for the measuring points is up to 7. So that means for the 7UT85 we have up to 5. Now we have up to 7 current 3-phase measuring points and so on. And you see here now there is a difference to the 7UT85. We have 1 time differential protection for standard transformer and 2 times the differential protection for auto and special transformer. Later on I will explain a little bit more why this is an advantage for you compared to the C-Protect Forward. So, and here as well, so we have also all these main functions on board for the 7UT86. And last but not least in our series, the biggest baby what we have already is the 7UT87. This is a multiple winding transformer device, so which is used in power plant application, unit protection, or small busbar application as well. So this device supports up to 5 transformer sites, and here we have the possibility to connect up to 20 measuring points. This is a lot of numbers of measuring points. I would recommend, if you start the engineering for that device, please try it in Dixie before that the load model in Dixie tells you if it is possible to upload the configuration to the device or not, that the CPU is not overloaded yet. So, but here there is one special thing. So that means now we have the multiple winding differential protection here. So that means these devices supporting up to 3 times differential protection for transformer, auto transformer, and special transformer. Special transformer means all these transformer which is not a standard transformer, for example phase shifting transformer, effect transformer, or converter transformer, which has a phase shift unequal of 30 degrees. So then also the numbers of functions which can be instantiated is more. So that means we have the restricted earth fault, which can be instantiated many times more. We have also the 1-to-3 pole tripping functionality, especially when you are using the line protection, the distance protection, and you are using that device in a high voltage application. So that means as well as the line protection devices with the 87 series here, the transformer protection devices also supporting the 1-to-3 pole tripping functionality. So, and here you see the much more numbers of measuring points. So this is a limitation. So, but of course you have to deal with that in Dixie to show to see if it is possible to upload it to the device, that the load model in Dixie tells you, okay, it is possible or not, or you have to delete some functions or not. So the rest is still the same as for the other devices. So this was a short overview about the transformer protection devices. So I would like to give you on the next slide an overview about the predefined hardware variants. So that means for each device type, we have already predefined the hardware variants. You can find these hardware variants when you open the configurator, and you can start with these hardware variants, which is equal to some standard applications in the field. But this gives you only a basis, and you can change these hardware variants as you need for your application. So on that slide, on the next slide, you will see our online configurator. I know you already know this online configurator tool. That means you select the 7UT and then select the right device here. And in that regards, we have the 7UT6 here as an example. You can change the modules. You can add some current terminals with sensitive or non-sensitive inputs. You can also add communication, protection function points to select the right protection functions. You can add, you can have a bigger display, a smaller display, key switches, push buttons, everything. So you can define the whole device into that configurator. And if you are finished, you use the ordering code, go into Dixie and start with your parameterization in Dixie. Okay, so this was a short overview about the device types or the hardware. So, and now I would like to hand over in the typical applications so that we discuss some typical application where the devices can be used. And I think to select the device, it is not really complicated because you have to count only the numbers of measuring points and transformer sites. So, and my first application is a simple two-winding transformer application. Here, as we can see in that picture, so we have the two-winding transformer application. That means we have to count the numbers of transformer sites, 2 in total, and also we have to count here the numbers of current measuring points. And with this information and the information from the customer, we can select the right device. In that case, I would select the 7UT82. So because there was no request for voltage, no requirement for voltage functions or so on, and also the limited hardware for binary in and outputs is absolutely sufficient for that application. So that means in the end, we select the 7UT82 for that, and you will see, okay, the device functions is on board. That means we have here the differential protection with the special features or additional features for inrush detection, over-excitation detection, and of course the CT saturation detection. And we have the flexible configuration of each transformer site. That means this device can be used for standard as well for auto transformer. So in the end, this device or the complete series offers you that you can reduce your investment. That means you have one device type for different applications. You have a simplified parameterization. You reduce the wiring in the cubicle, and of course you can shorten the commissioning time. So on the next slide, we go a little bit more into the function group concept, and this is a little bit the first part where we need to know how the function group concept is working. So ZProtect 5 is basically is based on the function group concept. That means the function group is like a container. Here in that picture you will see function group transformer site, function group transformer site 2. We have a function group for the transformer diff. So why we have this? Because ZProtect 5 architecture is object-based. So that means for you on the primary side, you will find the transformer with the 2 sides. You will also find the current measuring points, and this is also this is also shown on the parameterization. That means you have to connect the current transformer to the measuring points. You have to instantiate the measuring point to say, okay, measuring point 1 is connected to the high voltage side, measuring point 2 is connected to the upper or low voltage side in that case here. And also the circuit breaker has its own function group here, and you see it here that the circuit breaker we have two circuit breaker in that application, and you will see also in the function group concept there's a FG circuit breaker which contains an input for the current and the control of the circuit breaker, and finally the control of the circuit breaker is sending the trip to the circuit breaker on the primary equipment. So, and the interaction of these different function groups is made in Dixie, so that means you have to do the routings. Of course, here we have some application templates. You can start with these application templates, and for such a simple application, we have the transformer basic application. So that means the transformer basic application template contains the two transformer sides, the FG transformer where we have the differential protection inside, and you see here with the gray lines that these function groups are connected with each other. So that means we got the information from side 1 and side 2 and hand over the information, the measuring values, to the differential protection in the end. And of course, you can also instantiate here additional protection functions, which is site related. So for that regards, or for these application here, you have the overload protection on the high voltage side, and on the low voltage side of the transformer we have instantiated and simple overcurrent. So this is one of the first applications. Now we extend a little bit more the application, and we have now a 2-winding transformer, and additionally we have a restricted earth fault here because we want to measure the earth current which is flowing into the transformer in case of a winding fault, and therefore we can offer now a high sensitivities at one phase to ground faults here. So if we have a look on the picture here on the right side, then we will see our application from the slide before is a little bit changed now. Additionally to the 2-winding transformer, we have now a neutral point, which is solid earthed here, which is connected, and there we have also a single current transformer, a single phase current transformer, where we want to measure the ground faults. So for that application, we can also use the 7UT82, because now we have two current transformer 3-phase, we have one current transformer single phase, we have two sides, and additionally we need a neutral point. And therefore we have also an application template predefined in Dixie. You can start with 2-winding transformer with REF. REF stands for the restricted earth fault protection. So the rest is still the same, and I will jump over to the application. Here we have now the same picture as before, but now we have a new function group which is in the middle, the function group transformer neutral point, and you see the function group transformer neutral point have an input for a single current measuring point, so that means it is connected to this current transformer in the neutral point, and we have instantiated two single phase overcurrent functionalities into the neutral point, so as an additional protection for the neutral point in the end. And now you will see in the transformer side 1 there's an additional function in this orange box or orange circle, and this is the 87N. The 87N stands for the restricted earth fault. So, and the 87N is comparing the 3I0 from the lead side of the transformer with the measured neutral point current, the zero sequence current, which is flowing over the neutral point. And if there's a fault inside or close to the neutral point, then we will detect these with an REF functionality, which is much more sensitive than the differential protection. But you see here as well, that means the application before is only a little bit more adapted. So that means we have the same look and feel, the same structure as before, and now we add some additional functions on function groups to that project. Here in the end, you will also see when you compare the basic two-winding transformer application with that application, now you will see that also the circuit breaker function group has now the breaker failure protection instantiated. So next step, and this is a typical application all over in the world. Here we have the so-called two-winding transformer in a 1.5 breaker scheme application. So that means now we have the same application as before, but we have now a 1.5 breaker scheme. And here, this is how the application looks like on the right side. So that means now we have two measuring points on the high voltage side, one measuring point on the low voltage side, and we have a single phase measuring point on the neutral transformer. So, and this is quite easy to select now the device. So that means due to the limitation of the non-modular series of the 82 series, I need to select the 7UT85 here, because now I have three-phase current measuring points, and this is only possible with an 7UT85, 86 or 87 because of the modular hardware. So that means we use the basic module plus one expansion module for that, and then we can start here with this application. So the rest is still the same, and now we have a look into that application. So that means here you see that now both current transformers from the diameter are connected to the transformer side 1. And we have additionally one circuit breaker. So that means now we have 3 circuit breakers as in the picture on the left side. So that means in a single line you can count 3 circuit breakers, you can count 2 transformer sides, you can count the 3 current transformers. So, and in the end you select the right device. You arranged your Dixie project according to the needs on the primary side. That means here now we have the transformer side 1, which we have connected 2 currents. We have the neutral point as in the picture before, and we have the low voltage side. All functions or all settings which is related to the transformer side will be set or will be parameterized in the transformer side. This is, for example, the rated power, the rated voltage. Is this transformer side connected to ground or not? That means is it isolated or grounded? So all these functionalities will be parameterized in the transformer side. So next step, and this is a typical application what we have all in the world. So that means we have an auto transformer bank with a delta winding, and we have additionally these auto transformer in a 1.5 breaker scheme. Therefore, of course, we need a flexible hardware because we have a lot of measuring points now, and we want to protect the whole application with one device. Additionally, to the conventional differential protection, we want to protect here as well these auto transformer with an 87 node. That means with the node point protection beside the normal 87T. So that means we have 2 times differential protection in one device here, and therefore we have to select minimum the 7UT86, and this is clear. This was new because in the Cyprotec 4 world it was not possible to have 2 times differential protection independently in one device. So therefore also we have an application template available. That means you select this application template and start your parameterization. Now we need the beside the power transformer, we need now the auto transformer, and of course for the auto transformer we have also function groups. So, and that means now we have a look on that application, which is a little bit bigger now. So that means we found now in this application a function group: auto transformer side 1, auto transformer side 2. We also find here the auto transformer ground side. and as well because this auto transformer has as well a delta winding, and we found here this delta winding as well as an additional function group. And for that special case where we have 2 times the differential protection, please have a look here on the function group in the middle, function group auto transformer. This function group contains now 2 times differential protection. That means you can instantiate here 2 times the differential protection in that project, and then you can make the selection in the settings if it is a normal power transformer or a differential, or is it a node point differential protection. So, and for that application, you see it as well here. We have up to 4 function groups circuit breaker. So, and this is what I explained before. So that means now we have 2 times these differential protection instantiated. It is the same function, but you have 1 parameter for the protection mode. That means you instantiate here in the auto transformer diff 2 times the differential protection, and then you go into the settings, and then you can do the selection protection mode for transformer. That means including the delta winding, auto transformer plus including the delta winding, and here the 87 node is working only for the galvanic coupled windings. So that means auto transformer side 1, auto transformer side 2, and the ground side. So, and everything is galvanic coupled with each other. So therefore we need only a simple current node protection. So then we have here an additional application. For example, we have a step-up transformer with up to 6 measuring points. So that means now the application gets bigger and bigger. This is a typical application here for unit protection, for example, where we have generators connected. Maybe this is an industry application where we have a 3-winding transformer, and on the upstream side of the transformer we have up to 4 sides or 6 4 current measuring points or 6 current measuring points. So that means in the end the 7UT is flexible enough to do that. So here, for example, for that application you can start with the 3-winding application for 1.5 breaker scheme, and you can extend these to handle all the 7 measuring points here in the device. That means on the upstream side you can have additional functions. You can also have additional differential protection. For example, here on the upstream side you have 2 auxiliary transformer. If these transformers are not too small, you can also use for that a differential protection as you want. So then I talk about that in the beginning, so that we have also the possibility to protect converter transformer. And here for converter transformer we have sometimes a lot of measuring points to be considered, and as well one challenge is that these kind of converter transformers are unequal of 30 degree. So that means they have a user-defined or special phase shift. For example, sometimes these kind of converter transformers have 7.5 degree, minus 7.5 degree, 11.2 degree, or so on. So we have the possibility, by adding one additional function block to the differential protection, that you can select now a user-defined vector group. That means user-defined phase shift, and then you can type in the parameterization that these kind of special transformer have a phase shift of 11.5 degrees. So that means with this adaptation of the normal differential protection, is it possible to adapt or to protect these kind of special transformer like a normal power transformer, and you can use the sensitive settings as for a normal transformer. So one advantage of this flexibility and also of the power of our system is that you can also protect with one device 2 transformers. So I was doing that, or I was explaining that in the first slide, so that the 7UT87 is finally supporting up to 3 times differential protection. So, and here sometimes we have such an application, so where we have 2 transformers in parallel, and the customer would like to protect here two transformers in parallel by only one device. So that means if the application is not in operation or the device is out of service, then they switch off the transformer. Of course, you can also double here the device, that you have a redundancy. That means you can protect with one device 2 transformer, and for the redundancy purpose you can double the device, and then you have of course a 100% redundance for both transformer. In the past you have as a redundance device usually an overcurrent device, but here if you double the device you have 2 times the differential protection, and you have the full redundance and of course the full sensitivity to protect your transformer. This is a very cost efficient solution here, so that you have 2 transformers in parallel and you want to protect these with one device. Of course, there is some boundary conditions during testing, so that means you have to be careful. If you want to test one of the transformer differential protection, then you have to consider some countermeasure, that you do not inject the currents on the other transformer which is already in service, that you do not trip during testing. But therefore we instantiated, or we implemented a lot of functions and behaviors, mode behaviors, that you can separate it, each function from each other. So that means you can handle these. Transformer 1 is bay 1 and transformer 2 is bay 2, so that both functions are working independently from each other. So that means one of the transformer can be in service, the other one can be tested. So, and then since many years we have also an implemented voltage controller functionality, because a lot of customers was asking for voltage control function, and we implement these as well in our system. So that means you can have the voltage controller function inside the transformer differential protection. You can have also these functions as an additional functions. For example, if you look for a dedicated controller device, you can add these functions in many device types more. And if there's no protection function instantiated, then you have your standalone controller device. So, but here for that application, I think this is really a good example here to cover everything with one device here. That means we have the voltage control, we would like to have the protection of a 2-winding transformer, we have the adaptive adjustment of the differential protection. So that means when we capture the tap position, we can also read the tap position for the differential protection. That means there is no need any longer to do some adaptations in the settings, so to consider the tap changer. So that means the device is reading out each tap position, it is correcting the tap change error per step. And here we have also an application template for that. That means we have the 2-winding transformer plus the voltage controller. You can start with that application template, and clear due to the integration of the voltage controller, we reduced of course the investment. We have the tap position supervision. We can correct the false differential current, and we have the flexible operation. And in the end, also for your application or for your substation, it is easy to handle, because everything is coming from the same architecture, from the same platform, and also the protocol implementation, so that it's quite easy. I know that sometimes many customers struggling with third-party devices when they implement the third-party devices in an IEC 61850 world, and then sometimes the problem starts. And here we have an implementation which fits perfectly to the whole substation. And if you have a look here now on the single line, you will see here that beside the transformer side 1 and 2, we have now a function group which is called voltage controller two winding, and these same function group as for the protection function groups contains now the 90V function, which is the AVR function, and the control block. And with the control block we send a higher and lower command to the onload tap changer to give a higher or lower command in case of the voltage. So that means also here this application is now for standalone transformer, but with version 750 with 7.0 we now supporting also the parallel, or since 7.0 we supporting also the parallel operation. Next topic is which was coming up over the years from the experience what we have from the field. So that means a lot of customers was asking for more protection functions beside the main protection functions, the transformer protection function. They ask for distance protection, for example, especially in distribution grid or in transmission grids as backup protection function. So, and then of course we add the distance protection to our C-Protect transformer, C-Protect 5 transformer world. So that means now you have the possibility that the transformer can protect the dedicated the transformer as well. We can have 2 times instantiation of the function group line, and we can have a distance protection, or we can have as well here the line differential protection. So that means in the end this is also in reduce, you reduce the investment. That means you don't need an additional line protection device. That means the transformer protection can also handle the task of the line differential or the distance protection. So, and this is how it looks like. So that means beside the transformer sites here for these 3 winding transformer, we have instantiated here on the downstream side of the 3 winding transformer in function group line, and the function group line contains here, for example, the distance protection. So, and this shows you the flexibility what this kind of product has. That means you can use the functions from the library, put it into your project, and find the best solution for your application. Sometimes I say during my trainings and explain that there is different way to come to the same result. So there is no strict way to have to do that like this. You can play with the functions, you can play with the function groups that the application is cover your real world, and this is really a big advantage of the flexibility of the C-Protect 5 system. So last but not least here, we can also protect with the transformer protection motor. Motor protections, for example. That means here, if there's a need for motor differential protection, you can do that as well. That means also in the C-Protect library, transformer library, you will find here the transformer, the motor protection sites. That means motor site 1, motor site 2, and then you can instantiate here the differential protection for a synchronous motor or for an asynchronous motor. But this is an additional to the motor protection devices. So that means if the customer have only a simple motor protection device and used, for example, a 7SK82 without differential, then they can use here, for example, a 7UT85 to extend the basic application to a differential protection. Good. Yeah, this is how it looks like. So that means now we don't have the transformer sites, now we have the motor sites here, and of course the structure looks similar to a 2-winding transformer. In the end, now we have the 87M here instantiated to protect this motor here. Yeah, since years we have now the need or the request from the customer for central protection for small substation. Basically due to the fact that we have more and more process bus application, that we talk about more and more digital substation. This is also a good example here where we have the transformer protection, which is the server, and we have in the field here the merging units. So that means on the upstream side we have a merging unit which is providing the SMVs here to the transformer protection, and then we have additional merging units in each feeder. So, and this is really a good example here for a small central protection application. And here especially we have also a mix application, so where we measured the currents on the high voltage side directly via copper. So that means the device is directly connected to the current transformer, and on the upstream side of the transformer, because of the sometimes of the length of the distance between the devices. So we have here merging units, which is close, located close to the process, and they send the sampled measured values here directly to the server, and in the 7UT the differential protection is running, and overcurrent protection is running, for example, and directional overcurrent is running. So that means here we have one central device which is protecting the whole application. And one additional functionality is as well that here we have the master clock implemented in a device. So that means we can synchronize via the 7UT all the merging units in the ring. So that means that there is no need for an external clock to synchronize here all the merging units. So, and for example, when in such an application the main protection fails here, that means we have the same application as before. So that means our 7UT fails due to some defects or so on. So then of course we have the possibility as well here in the merging units. So that means the merging units also support backup protection function. So that means you can run these application again, or the application can be run. So that means there is a basic protection functions available. So there is no need to switch off the whole application. Okay, so this was the second part. Now we come to the third part of my presentation, and therefore we want to talk about the functional improvements. So that means we did a lot comparing to CPROTEC 4. That means now we have a lot of functional improvements regarding the differential protections, and I would like to show you which kind of functional improvements we had, what is important to know, what is also important to know during testing, because therefore you will see there is some difference, and this will be explained in the next slides. So that means the first thing what we change is the improvement of the restraint algorithm. Due to the fact that we have many more 1.5 breaker scheme application with a small power transformer. For example, this is an auxiliary transformer for the station bus or so on. And we have in the past with the existing restraint calculations from issue for an overstabilization. So we change now the philosophy of the calculation of the restraint current. As you can see there in the gray box, we changed only the equation. So that means now we use for the restraint calculation the maximum current of one measuring point. So that means in the same case, we do not calculating or summating all the measuring points together. We use only one. Therefore, we come on the x-axis a little bit more on the left side, and that means when we have high currents which is flowing over the bus bar, and at the same time we have an internal failure, we are much more sensitive than before. So that means we have a higher stability against external faults, but we are much more sensitive again for internal faults with low fault current. So, and this offers us to have really a good sensitivity in case of such an application. So, and this was the reason why we changed that, and this is the first change what you will see when you test the differential protection. That means if you test the differential protection with an Omicron differential module, then you have to change now the restraint calculation. So the next improvement, and this was a really good improvement because we used that implementation from the busbar protection. So that means we have now a very short tripping time. That means when we have high short circuit currents, internal faults, then we can trip immediately. Because the differential protection, the fast stage is working now with an instantaneous method, and also you see here on the right side that the characteristic is now changing. So that means our characteristic has now a slope, and the new fast differential algorithm can distinguish between internal and external faults on few samples. So, and this is of course what I explained to you. This is proven from the busbar protection, and due to the fact that the characteristic is now changing, we can also bring the characteristic a little bit more down. So that means now the rule for setting the the fast stage is the only rule for that is that you have to set the the fast stage over the maximum expected inrush current. So, and that's for the most of the transformer. That means from 100 MVA transformer, we have to set the EDIF greater stage, for example, to 4.5, for example, and this offers us a very fast tripping time in case of an internal fault. Good. So then, of course, we was struggling in the past with the inrush stabilization. So in the past, the inrush stabilization was based on the second harmonic. That means on the 100 Hertz component, and sometimes this was not able to energize the transformer by first time. So that means you have to switch on again and again until enough second harmonic was in the differential currents available that we can block the differential. Or I was doing that during my commissioning time. So that means I was blocking the differential protection. Was enabling only an overcurrent protection function so that I could energize the transformer. But now we learned from the field, so, and we was implementing a new second method, and beside the first method to detect the second harmonic, we have now the so-called CWA. CWA stands for Current Waveform Analyzers, and we here checking the flat area in the differential current. So, and these flat areas are this is a typical waveform during an inrush. So that means now the device is have two methods which is working in parallel, and if one of these methods is coming to the decision that we have an inrush, then we block the differential protection. So, and here we use that CWA. The CWA functionality is working like a cross block. So that means we have to detect minimum in two phases these flat areas, and this CWA function is working dynamically. So that means here we have a dynamical algorithm which is checking how high is this flat area, and then we block the differential protection for a certain time. So In the end, we also use here the CWA functionality also in CPROTEC 4, because the experience with the CWA functionality was so good from the field that we also implementing the same algorithm, the same philosophy also in CPROTEC 4. So, and since that time we have less stress with MAR trips. So therefore, we are really happy to have this second method. And of course, also the world or the transformer manufacturer is doing some changes due to noise reduction in the transformer, due to decrease decrease the losses in the transformer, and therefore also new transformer with new core materials do not injecting so much second harmonics. So therefore it is really good to have here a second method to energize the transformer. And beside the CWA blocking for inrush, we use also the CWA functionality here to detect internal faults, because when you have internal faults, you can also have CT saturation, and CT saturation produce also second harmonic. And I saw some cases where the customer was setting the second harmonic content or threshold to 10%, and also the crossblock to infinity. So, and that means when the transformer have an internal fault with CT saturation, the device will see these second harmonic content and will block the differential protection in case of an internal fault. So here now we have the CWA internal fault detection. So that means that this second method from the CWA algorithm is checking if is this a sinusoidal, looks this like a normal internal fault, then we suppressed the blocking of the second harmonic. So that means now we have the possibility to trip earlier, to do not wait until the cross block is over, until the blocking time is over, and so on. So that means the CWA internal fault detection helps us a lot to react faster and to protect, of course, the transformer, and in the end also the humans. But here, of course, when the CWA is enabled and you want to test the second harmonic blocking via this Omicron test module, you will get always a trip. So that means the second harmonic blocking is then not working. Why it's not working? If you have a closer look to the test module from Omicron here, then you will see that these second harmonic inrush or second harmonic blocking is only a fundamental wave with a second harmonic or 100 Hertz component overlaying. And of course, this is not the truth in the real world. So that means that this looks like an internal fault with some second harmonic. So therefore, our device will be tripped. If you switch off the CWA, then you will see our device will block in that case. But of course, you want to check both, or you want to test both algorithm in parallel. My recommendation is, when you want to test both, please use a transient test file, or use a transient test file to check if both methods are working correctly. So it is not possible any longer to test these with steady state conditions or steady state test algorithms or test modules. So we have also used the same implementation here from CPROTEC 4. So that means our 7UT has an CT saturation detection. So that means we are doing that with these add-on stabilization area. So due to the fact that the restraint current calculation is now changed in CPROTEC 5, we have the possibility now to move the add-on stabilization more to the left side. So that means that the operation point or the device is earlier reaching this add-on stabilization area, or we call it external failure detection. So if we reach that area earlier, then we can temporarily block the differential protection in that case. And due to the fact that we reaching that algorithm earlier, so we can also reduce we can also reduce the CT requirements. So that means in the end, we reduce the transient dimensioning factor. In CPROTEC 4, it was 3 for transformer protection. Now we have a KTD of 2. So that means you can build the current transformer a little bit smaller. And this also save money because now we have lower CT requirements. So, last but not least, in CPROTEC 4, we had sometimes the topic with the matching transformers, or with the adaptation factor. So that means sometimes we have a 3-winding transformer with side 1 and side 2, which is very big, and then we have a delta winding connected, which is very small. And due to the fact that we have very low currents there, we have a CT mismatching. So, and due to that fact, we was not able to connect the third side to the differential protection, or in that case, so if we have a for example, if we have a busbar connection, so where we have very high currents, so therefore we have to select a big current transformer. In that example, for example, we have a 1000 to 1 amp current transformer, but the object named current on one side of side 1 of the transformer is only 100 amps. So, and therefore we have a mismatching factor of 10. The limitation for CPROTEC 4 was 8. Now we have a theoretical value of 100. A practical value is around 30, 40. So, but due to the fact that now CPROTEC 5 has a really high resolution for the measured phase currents, so that means we are using a 24-bit ADC converter, and this offers us to measure also small currents beside the sides with the high current. So therefore, it is no longer necessary to have here matching transformers, because also these matching transformers bring sometimes problems during commissioning, problems with, for example, with CT saturation, problems with higher burden, and so on. So that means we are much more flexible than CPROTEC 4 with the implementation in CPROTEC 5. So, and for you, the message is that we have no limitation regarding the CT mismatch anymore. So then, of course, beside the overexcitation blocking, we have also an overexcitation function implemented here in the 7UT. You can use that functionality, so that means we have now 2 different kinds of function. We have an defined stage, and of course we have a user-defined stage here, which can set to your needs. So that means according to the given data from the transformer manufacturer, you can have here 2 stages available: the user-defined stages and a time-dependent characteristic. So, and this can be set as an the thermal characteristic can be defined by 30 pairs of voltage and frequency, and in the end you have a perfectly adapted to the given data from the transformer manufacturer. So here again we have this topic with the voltage regulator. So that means we can control the voltage of an auto transformer, of a power transformer with a motor driven tap changer. We have different implementation: 2 windings, 3 winding, and a grid coupling transformer. We can capture the tap position via binary code. We can capture also the tap position via goose signal or via an analog signal. So the parallel mode is also supported since version 7.0. We have the voltage controller functionality for automatic and manual mode. We have the linear and inverse control response, especially here in Europe. We have also the possibility for a dynamic voltage control. That means in regards to the actual flowing or actual power. So that means in power, in case of a power direction, we can control as well the voltage, the target voltage. We can set up to 4 fixed target voltage in the settings, but we have also the possibility to send each target voltage via the SCADA system to the controller. Then all the blocking conditions are on board. So that means for overcurrent, undercurrent, overvoltage, undervoltage, everything is on board. We also have the possibility when the voltage controller is instantiated in the transformer diff, then we can block the voltage controller during abnormal conditions. That means when the differential protection is picked up, then we have the possibility to block the voltage controller in that case. So, and as I said, we have the voltage control for 2-winding, 3-winding, grid coupling transformer, auto transformer. We have the supervision and the control of the motor-driven tap changer. We have the line drop compensation. We offer the flexible communication with different communication modules or communication protocols to the SCADA system, to the station bus and so on. So that means also the voltage controller can talk to T103 or IEC 6150. So that means we have also the possibility for multiple protocol implementations in one device. So for you, this offers a very flexible application. So in only one device, for standalone device, or for example, also in a standalone device. That means you can combine it as you want with protection, or you can use the function in a single device, for example, 7SJ, 6MD, and then you have a standalone voltage regulator. So, and this is the topic here again, to the voltage regulator. So that means how we come from a single controller to a parallel control operation. So that's quite easy. So that means now we have for each transformer his own voltage regulator, but all the voltage regulator are communicating with each other. Then we did it with the IEC 6150 goose communication, that we send all the information from one side to the other side, so that we can control here up to 8 transformers in parallel. The interconnection, as I said, is done via the IEC 6150. We have the following modes available. They have the master following mode. We can support the circulating current minimization, and we have also the independent mode in case that one transformer is not connected to the same bus. So then we can also control the voltage in the independent mode. So that means the function is available since version 7.50. Now we are working on the graphical single line topology, which is similar to the busbar protection. That means we want to check which transformer is connected to which busbar, and only the transformer which is connected to the same busbar have his own voltage control group. So, and this is really similar to the busbar protection, where we have the different check zones, and we estimating these, or we detecting these via the position of the disconnector and circuit breaker. And this, of course, it's much more easier than for you. That means there is no need any longer to do that via a CFC plan. Good. Yeah, then one topic which is also very interesting So that means we also offering the possibility for the 7UT that we can protect phase shifting in special transformer. I talked about that before. So that means now we have the possibility in our differential protection that we can add an additional function block and can say, okay, we want to protect a single core transformer, we want to protect the two core transformer, phase shifting transformer, or we have this kind of special transformer. Here on the right side, we see such a single core transformer. So that means for such a phase shifting single core transformer, we have the influence of the tap changer into the series winding. So therefore, there is an influence of the voltage and as well of the phase angle, and this needs to be corrected by the differential protection. So how we do that? We do that by capturing the tap position, and if you instantiate the function block into the differential protection, then you can have two tables and you have to fill out the tables. One table is for voltage, the other table is for the phase angle. So and therefore you can protect such a important phase shifting transformer, especially for the transmission grid, as a normal transformer. So that means the differential protection algorithm is doing the adaptation, and this transformer can be protected really as a normal transformer with very sensitive settings. Yeah. Here, therefore, you can use the standard transformer differential protection, and you're adding, as I explained before, only an additional function block for phase regulating transformers, and then you got these additional settings. So that means in the end, also the 7UT devices are suitable to protect phase shifting and special transformers by these special adaptive adjustment of the differential protection. And this is really a good advantage of the whole system. That means the look and feel is the same, so there is no dedicated application necessary or adaptation of the application necessary. That means you can use the standard differential protection also for these kind of special transformers. So, and last but not least, we have a look here onto the migration part, and here on the left side you see the CPOTEC 4 devices, which is already phased out. So that means end of this fiscal year in September, you can do the last order for the 7UT 613, 633, and 635. And after this date, it is not longer possible to order new devices, CPOTEC 4 devices. So that means now everything is now covered into the CPOTEC 5 world, and you see here you have the modular series and the non-modular series. You see the 7UT 612 is equal or is comparable with the 7UT 82, but of course if you need more binary in and outputs and voltages, of course then you can step over to the modular series 7UT 85, and the rest is going to the modular series, means 7UT 85, 86 and 87. And last but not least, I would like to mention as well here the 7SX85, which is also available. The 7SX85 stands for our universal protection device. So that means this device can fulfill all the protection application as you want. So that means with this device you are much more flexible than the 7UT. So that means you can run this device as an overcurrent device, line differential, distance protection, transformer protection. It can be in a motor protection, it can be in generator protection, and so on. So that means you have the choice of the different types of device, type devices as you need, and for your especially for your application. So in the end, I would like to give you an overview about the benefits. So that means we have a comprehensive transformer differential protection, increase the system availability, reduce especially investment, is adaptable to your application. That means special transformer, phase shifting transformer, transformer with voltage regulator, transformer with line differential protection together, and so on. That means this device is like a universal device, but based on the transformer protection. So, and in the end, the whole device is future-proof. That means also you can have these transformer protection device in a digital substation. That means we supporting the process bus application, and in the next step we as well supporting also the possibility to connect to LPIT. In the modular series we have already the possibility to connect to non-conventional transformer, and also in the 82 series we will get in the near future the possibility to connect to non-conventional transformer like Rogowski coils or air divider or capacitance current transformer. And that's all from my side. I hope I can give you in my first session an overview about the protection functions, the new implementations, the improvements, the flexibility of our system. Thank you very much, and see you later to the next session.
저희 파일은 그런데 이제 24년도에